Hello, let's continue our Sudoku adventure with King's Bounty by Frappy. So we have irregular 6x6 Sudoku rules, which means in every row and every column and every bolded outline region, we are placing the digits 1 to 6 exactly once each. So our regions are not our normal 2x3 boxes. Instead, we have these bold outline regions like this one, this one, this one, this one. It's kind of a neat pattern here. Additionally, we have cages in the grid. Those are these cells surrounded by dotted lines. Digits can't repeat in a cage, even if normally you could. So we could put, normally in Sudoku, we could put a 1 and a 1 here in our irregular regions. But because they share the same cage, we're not allowed to. And the digits in the cage sum to the value in the top left, if given. So these 4 sum to 11. We don't know the sum of these 4. We just know they can't repeat. But these sum to 11, these sum to 13, these sum to 13. Additionally, we have anti-king. So that means any 2 digits that touch in terms of sharing a border or a corner cannot be the same. So this can't be a 4, right? Because then we'd have these 2 4s touching each other. So that's anti-king, also sometimes called no touch. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. All right, how do we want to get started? Something I'm interested in is 4 in this column. I think, I don't know. Yeah, I think we can place the 4 in this column. Yeah, because this 4, we can't be touching this 4 and we can't be touching this 4. So there's only one place for 4 in the column. We can place that immediately. We can probably think about math, but do we need to yet? Yeah, we might as well. So let's look at this 13, or let's look at this 13, because we already have a 5 in it. And this is going to probably be the most limited. Actually, 11 we already know. 11 in 4 without repeating a digit is always 1, 2, 3, 5. It's the only way to do it. The minimum is 1, 2, 3, 4, which is 10. So we have to add 1 to something, but the only thing we can add 1 to is the 4, because if we add 1 to any other digit, it would repeat a digit. Like we could do 1, 3, 3, 4, but that repeats the 3. We're not allowed to repeat. But let's think about this. These 3 digits add to 13 minus 5, which is 8. So to add to 8, it's either going to be 1, 2, 1, 2, 5, or 1, 3, 4. 1, 3, 4 is a little bit harder because that can't be a 3, and these 2 can't be 4s. Okay, so we always have a 1, right? One of them's going to be a 1. If we were 3, 4, then this would have to be the 4, and then one of these would be 3. If we were 1, oh, and we can't do 1, 2, 5 because there's already 5 in the cage. Right, so it is 1, 3, 4, and that actually, hold on, how does this work? Yeah, this has to be the 4. It's the only one that can be 4, because this can't be 4 for the row, and this can't be 4 because it touches a 4. And then we end up with a 1, 3 pair here. Okay, yeah, that makes sense. Now these have to add to 9 without a 4, so they can't be 2, 3, 4, and they can't be 1, see, they could be 1, 2, 6, but they can't be 1, 3, wait, 1, 2, 6 or 1, 3, 5 is what's left. 1, 2, 6 or 1, 3, 5. Is there any way to tell the difference? Well, we know there's a 1 in them. We can at least do that. So I guess one question to ask is where does 1 go in this column? It's not here because the 1s are used up. We need a 1 here and we need a 1 here. That's all the 1s these 2 rows get. So these can't be 1s. These can't be 1s. So basically we don't have 1s in any of these. So the question is, no, the problem is I don't know that there's a 1 in here. So I don't know that I can necessarily do anything with that. I guess this is a region. So if this is a region, we know what these 3 digits are. They're the remaining for the region. We need 2, 4, and 6 here. And this 4 sees both, this 4 sees here and this 4 sees here. So this is the 6, sorry, this is the 4. 2, 6 pair means these are not 2s. So the 2's up here somewhere. 5 sees here, that's not a 5. So this is not 2, 4, or 6. This is 1, 3, or 5. because it touches the 2, 4, and 6. Three. Is it 4? 4 in this. Well, 4 in this region here. It goes in one of the. Actually, it goes only here. Yeah, this 4C's here. This 4C's here. So 4 is placed in this region. And that's all of our 4s. Okay. So this is from 135 as well. So this cell here touches the entire 135 triple. So it has to be a 2. It's its only option. And that means this is a 135 triple. And this is a region, right? And so the 1 is used up in this region. This has to be 2, 6 only. We know the order. And then that places the 1 here. That's 3 and 1. That's not a 1. That's not a 1. What else can we do here? This 3 looks in, and this 3 looks in, so we can actually place this 3. The 3 actually touches this as well, so that's 5 and 1 and 3 and 1. And then this row's done. It needs a 2. That touches here. That's 6 and 2. This row needs a 5 and a 6. And this 6 touches that one. This region here needs a 1 and a 5. And we know the order because of that 1, 5. That's a 3. These 2 columns are done. This needs a 2. This needs a 6. This region needs a 6. It can only go here now. This needs to be a 5. This region needs a 1. This region needs a 3 and it needs a 5, and that 3 told us the order. And this column needs a 6 and this column needs a 2, and we're done. Congratulations, Tinestra. You have recovered the Scepter of Order from the clutches of the evil master villains. All right. Nice. All right, well, thanks, Rappy. That was a neat puzzle. I enjoyed it. Some interesting King's Move usage there, as well as the usage of the irregular regions. Quite enjoyed that. Hope you enjoyed this as well. If you did, then why not leave a like, subscribe, and a kind comment below.